Hello everyone, this video is to introduce our tool Sprinter, which is a Clang-Tidy based style checker for C++ smart pointer arrows. In the programming languages without garbage collection, such as C, C++, and Pascal, programmers should manually manage the memory, and these memory allocations and deallocations are always verbose and backprone. As a result, the improper manual allocations will lead to lots of common known memory errors, such as memory leak, double free, and etc. To prevent such memory errors, the smart pointers are introduced into C++ to automatically deallocate the memory that are no longer used. Although they are very helpful to reduce memory errors, improper usages can also lead to memory errors, and these errors are sometimes more difficult to be detected. We call them smart pointer errors. There are mainly three factors leading to smart pointer errors. First, the concept of the smart pointer is very confusing to the beginners. Second, the name of the APIs of smart pointer classes are also confusing and bug-prone. Third, since smart pointers are used to solve the memory errors, the programmer may be credulous to their code when smart pointers are used. Therefore, a good tool to check the smart pointer errors during compile time can be greatly helpful to avoid the memory errors caused by bad smart pointer usages. We extracted 10 error patterns of 4 categories by manually reviewing about 800 smart pointer related issues on GitHub and questions on Stack Overflow, and we implement our checkers based on these patterns. These patterns are unconscious ownership transfer, leaked ownership, forked ownership, and invalid memory ownership. An example for the unconscious ownership transfer group is listed in the shell. On line 14, the auto pointer is used as the template argument of an STL container. On line 10, a private auto point field is declared in a class with no copy constructors or assignment operators. To help the programmers debug the implicit ownership transfer of auto pointers, we also added a debug checker. With the debug checker, we can find the implicit transfer on line 17, which will trigger a non-pointer dereference issue on line 18. Here is the diagnostic information generated with Sprinter for these three patterns above. The second group of patterns are used to detect ownership leaked from smart pointers. An example of leaked ownership is listed in the shell, and the corresponding errors are marked in the code. The diagnostic information generated is like this. An example of forked ownership is listed in the shell, and the corresponding errors are marked in the code. Here is the diagnostic information generated. And finally, for the fourth group, an example of invalid memory ownership is listed in the shell, and the corresponding errors are marked in the code. Here is the diagnostic information generated. Besides, all checkers can also be separately executed. Here is an example of executing the debug checker on its own. According to the diagnostic information, only the warnings about the implicit ownership transfer are generated. Thank you for watching this video.